using Cartesian divers today to demonstrate density. And we've got a little water dropper and a 2-liter bottle. And this really helps people understand how ballast tanks on a submarine work. So I'm over here with table 1. And Chase, would you squeeze that 2-liter bottle so we can see what happens to the dropper inside? It drops. Now I noticed that when he stops squeezing it, bubbles don't come out of the dropper. So there's a little bit of air in there, but the air doesn't come out, and there's certainly no air entering the dropper. So the essential question is, what makes the dropper dive? What makes the dropper rise? So I'm gonna come over here and I'm gonna ask Madison. Madison, what makes that dropper rise and fall?
Okay, if the air in the dropper becomes more dense, water will go in and then it will die. And then when it rises, it expands and it forces it to go up.
Okay, now Chase, you're really strong. Would you squeeze that? So you said that when the air expands, it forces water out. So I see more water is entering the dropper. Oh, I see what you're saying. So if he stops squeezing it, then that little bubble inside the dropper, it starts to expand and it flushes the water back out again? Yeah. Because I don't see any bubbles coming out. Give it one more squeeze there. Squeeze that again. That forces water into the dropper. So I see the little water level rise in the dropper, and if he stops squeezing it, then the water level changes. Nice job. I'm here at table 2. Table 2, now you've got a similar setup here, and I'm here with Kyla and Caden. And why don't you give that a squeeze and let's see what happens. It goes down, and if you let up, it goes back up. Now, can you explain to me what makes that dropper rise and fall?
If air in dropper becomes more dense, water will go into the dropper and it will dive down.
Okay, so if I squeeze it, I see the water level actually rise in the dropper. That means that little air bubble becomes more dense. That little bubble of air becomes compressed, and that allows room for water to go into the dropper. And if more water goes in the dropper, it dives, doesn't it? Mm-hmm. Okay, what happens when I stop squeezing the bottle? What happens, Kyla?
The air, and it will push down, and then it will go up.
Yeah, the air expands, and you said it pushes down. So if that little bubble of air is pushing down, it's forcing water back out again, isn't it? And then the dropper rises. Good job. Now I'm over here at table 3. And here's your Cartesian diver. Little water dropper, a little eyedropper, and a 2-liter bottle. If we squeeze it, it starts to dive. So Ryan, can you tell me what makes the dropper rise and fall?
Okay, when it's less dense, it rises because the water goes down into the bottle and it goes back up. But when it's more dense, the water goes into the dropper and makes it go down.
Okay, now when you say it's more dense, are we talking about the little bubble of air becomes more compressed?
Yes.
Okay, right, because when I stop squeezing it, there are no air bubbles that come out of the dropper. It's the same amount of air in the dropper as when it's at the top side as when it's at the bottom. The air is just more compressed, right? Yes. Nice job. And I'm over here with table 4. Table 4. Okay, here's your Cartesian diver. Now, Lily, can you squeeze that? And down it goes. Okay. Now, Gabby, can you explain why the dropper dives and why it rises again? Why does it do this?
Because if you squeeze the bottle, then the air bubble becomes more dense, allowing room for the water to enter the dropper and dive.
Wow, that's awesome. Squeeze it again. That was great, Gabby. Great explanation. Okay, I'm coming over here to table 5 in the back. And it looks like, Alex, you've got your Cartesian diver, and it's diving. Now, I like yours because yours has a little propeller on it. So it actually spins when it dives. Isn't that cool? That's cool. Okay, now, Dylan, can you explain Why does it dive like that? What makes the dropper dive and then rise back to the top?
Well, whenever you squeeze the bottom, the air becomes more dense, allowing room for water and for it to sink.
Oh, so when that little bubble is under pressure, it creates room for more water to go into the dropper. And as the water floods the dropper, it dives. And then if you stop squeezing it, what does the air do when you stop squeezing it?
It becomes less dense, so it expands, so it'll push the water back out, causing it to rise.
Awesome. Yes, that's exactly right. It expands and it pushes the water back out. Now I'm over here to table 6. Table 6, here's your Cartesian diver, Christiana. So let's see if you can make it dive. Oh, that one died. Yeah, there it is. And then back up it goes. So you squeeze a little bit. You can see the water level actually changes in the dropper when you do that. So can you tell me why does it do that, Diego? Why does it rise and fall like that?
It's because the air inside of the dropper becomes more compressed, and it dives because it's under a lot of pressure, and water goes into it and it sinks.
So when I squeeze it, it's under more pressure. That little air bubble's under more pressure, and that allows room for water to come in, doesn't it? Mm-hmm. And as water enters the dropper, it starts to dive. Just like a real submarine's ballast tanks flood with water and the submarine dives. And then the submariner says, "Take her up topside!" And then the gas expands and flushes all of that water out of the ballast tank and it rises. Good job. Okay, so now we're over here at table 7. Table 7. Look at Ava. She's got her whole setup here. Ava, can you make it dive? Yes, just by squeezing it a little bit. And this is something you can do at home with just an eyedropper. And that little thing on the end of it, that's just a little brass hex nut there that increases the weight of the eyedropper so that with a little bit of water, it'll dive. And that's something I'm pretty sure you guys can find at home. So now, Alden, can you tell me what makes the dropper rise and fall? Why does it do this?
When it dives, the air becomes denser when you squeeze it, allowing more water to come in, and it sinks.
Yeah, the air becomes a little denser at that top, that little bubble up there. It becomes pressurized, and when it becomes pressurized, it allows room for water to come into the dropper. And you get a little more water in there, it starts to dive, doesn't it? Down it goes. Nice job, you guys. 6th graders learning about density and the effect that fluid density has on that little dropper. This also illustrates Archimedes' principle, too. Way to go, you guys.